Welcome to a new video. So patching some stuff that I added to DWM, making some minor changes to the the patch version of DWM that I call Patch OLD DWM, and which is basically a fork of Leaksmith's DWM, but without all the unnecessary bloat that he put into it. Not to insult him in any kind, but yeah. So this is a voiceover, as you may probably infer from the way my voice is presented, but let's talk about some future things for this channel and for me in general that I would like to do doing on this channel. My song is there. Alright, so okay, we guarded f to point f against a null pointer if open fails in any way, which would be likely the case with the backlist file macro, that backlist file not pointing to the file that exists. So it is basically a subsystem under the driver i912, I guess, that is embedded into the kernel. It is an Intel driver. So this is a subsystem that is exposed in the 6th class file system, and we are directly writing to the file that will reflect how to basically change the brightness of the display. And we're using the standard way, which is basically passing a struct, which is it's not a struct, it's a union, but yeah. So the instead of using shell scripts to directly make changes to the file, which will require root access, what we are doing basically is using the libc API to do that instead. But except for that, everything else is basically invoking shell commands, which could be done in and it could be done with just using the macro that is provided in the DWM that involves the shell commands along with the following arguments to the shell command. So yeah, we might as well do something different next time around when I try to patch. This is basically ancient code, and as you can see probably from the quality of the code, that's not very nice. That's not very good at all. I will like to directly interact with the subsystem under the i912, I guess. I don't know what the driver is called, but using udev to control the driver, how the driver behaves, or basically the subsystem, which is in the sysfs directory under the PCI slot that is used for the display adapter, which in my case is EDP. So it's a virtual DisplayPort adapter that basically is acted as a external monitor. So it should be the same as doing kernel driver development, kernel driver interaction with using an external constructor, I guess. So yeah, I guess it should work like that. And also, I'm also working on a patch of ZSH that tackles with a better configuration. Before the building process, you basically configure your software, configure it to compile and instruct the compiler to build system to compile with your desired flags. But GSH upstream source tree doesn't really facilitate um, not having to use the new user scripts that automatically invoke when in the absence of dot files. So there should be a mitigation around it and workaround that will basically have just one flag in the config.h file that will basically instruct the compiler not to compile for checking against the absence of those dot files. So that's something we will do, and also the history will by default embed directly into the source of the history ring buffer that basically stores your command strings to command strings, so you can use the ZLE for switching stuff around in the history ring buffer. Well, so by default the ring buffer is quite small. The capacity for the ring buffer is quite small. We'd like to enlarge the ring buffer size a little bit so it stores something like how Bash does that. So yeah, that's the plan for the future. And also I have a tensor library that basically enables you to allocate, manage, and do operations with arbitrary dimensional arrays. And that project has the allocator, the assignment, and the assignment, and the set-get functions ready for arbitrary dimensional arrays. And also it has some sort of operation that is like joining the arbitrary dimensional arrays to a new array, and it's all done in pure plain C. And it has the capability of Python-like subscripting, although the popular practice would be to use flat arrays with an augmented indexing that will simulate what it would be like to have multi-dimensional arrays. And yeah, it uses recursion at its core, which makes a lot of allocs and frees, and that's why it might be slow. But for smaller dimensional arrays, the advantage where it basically shines is not having to use any function wrapper around getting and setting the array data. So yeah, it's still not pushed upstream and still exists just as local, because I'm not confident enough that it still is functional. And although it passes all my tests using Valgrind or ASAN, but the performance penalty of using recursion, it's still still troublesome. And I'll include an option to basically basically use flat and indexing with index calculations with respect to higher dimensions, if that makes sense. So that's how basically it's done. So instead of using allocs equal to the power of these power of the size to, I mean, the power. Well, my brain doesn't work. I don't know how to phrase. Well, yeah. Sorry for all this jittering. I guess I haven't spoken for a long time, and in English especially, so it might sound a little sloppy and probably grammatically a little off. But yeah, it should work. Okay, so for the objective of this patch is to make Pazio DWM, like patch of the DWM, more portable to other systems. So it facilitates in the code a little bit of checking whether the wrapper around the control interface of your system is selected to be what your distribution provides. And that's why I want to basically directly communicate with the APIs, the user APIs for those for the systems. So for example, you cannot use pulse audio, you cannot use pipeware to pipeware. If you have basically to say that you have pipeware installed along with this the patch of DWM, your so controlling volume would not work as well, because it relies on the pack control command. So I would plan to basically directly use the ELSA APIs to change and modify, change and control volumes of your MasterCard. So yeah, I will integrate that to DWM, and probably that won't be much a dependency overhead because everyone uses ELSA at the end of the day, right? Sound servers are something built on top of ELSA using the ELSA APIs, providing basically a control device for the user to access ELSA controls. It's not really, ELSA is much lower level, and basically pulse audio and pipeware both are sound servers that does what ELSA does not. So it basically tackles how ELSA works. So yeah.